Good day, students. On this clip, we're going to go over how to use a given ratio to find uh, another trig ratio. Okay, so write this down. I'm using a using trig functions to find other trig functions. All right. So let's take a look at an example where we're going to use one trig function to find the value of another trig function. So number one, if sine theta equals -3/5, find the value of the other 5 trig functions. Trig functions. Okay. All right, and then we're gonna assume assume theta is in standard position in quadrant 3. Okay, so what we're going to do in this case is we're going to use this trig function to generate a right triangle, and then we can use SOHCAHTOA to finish it up. So if we want to generate a right triangle, and we know that sine theta is equal to -3/5, what ratio is this? We know from SOHCAHTOA that sine is opposite of a hypotenuse. So if you look at this, this is basically the top is the opposite over the bottom is the hypotenuse. So remember that the hypotenuse is always positive, okay? So we're going to create a right triangle in quadrant 3, and we're going to use this as the opposite and that as the hypotenuse. So what we're going to do is we draw a coordinate system. This goes my x and there goes my y. And the opposite, well, let me draw my right triangle first. We're going to draw the opposite, something like this. Make this the opposite. And then that's going to be the hypotenuse right there. Okay? So the opposite is -3, so this is going to be -3. Going down -3 units, I'm sorry. Put -3 right here. And this entire length right here is going to be -3 because it's going down -3. And then the hypotenuse is going to be 5. Well, how do I know this? Because the angle is always starting from the x-axis, right? Going down. So there goes my theta. And then if this is theta, that automatically makes this side my opposite, right? And since this is the longest side, there goes my hypotenuse, all right? And then this is my adjacent. All right, so in order to find all 6 trig ratios, we need to find what my adjacent is, all right? So I can use I need to find this side, adjacent right here. So I'm going to go, and I'm going to use the Pythagorean Theorem. A squared plus b squared equals c squared. So I can call this opposite, I can call this A, and then call this B, and then call this right here C. Alright? So let's plug it in, and then we're going to find what B is, which is the adjacent. So A squared is going to be -3 squared plus B squared equals 5 squared. So we're going to have 9 plus B squared equals 25. Subtract 9 from both sides. And they have B equals 25 minus 9 is 16. B squared equals 16, which follows that B is 4. Alright? So, but since we're going back, in this case, B is going to be negative 4 because it's going back. It's the left side, so B is going to be -4. Okay? Alright, so let's find out what the other trig ratios are. I already know sine theta is -3/5. And then from cosine is adjacent of a hypotenuse, so adjacent is -4 divided by the hypotenuse, which is 5. And tangent is opposite of adjacent, which is -3 over -4, which divides. If you have minus over minus, you end up with 3/4, and that's the final answer. Now for the reciprocal trig functions, sine goes with cosecant. The reciprocal of sine is cosecant. So cosecant theta is -5/3. If you reciprocate cosine, you get secant. Secant theta is -5/4. And then tan theta is cotangent theta. If you reciprocate tan, you get cotangent, which is 4/3. And there goes your final result. Okay? So basically, you're just using the given ratio to create a triangle. And then from there, you use SOHCAHTOA to finish off the problems. Alright? So thanks for paying attention to this clip. And be sure to subscribe to my videos.